Hey y'all, we are Memphis Community University and we are back for another Calculus Done Wrong lesson where we wrong calculus before calculus wrongs us. Today is a special day because we are doing a 2-in-1 special. First off, what we're going to talk about is we're going to talk about easy U substitutions. So basically when the inside function is just a line, mx plus b, we're just going to skip the U sub process and just immediately take the antiderivative and then do something that similar to the chain rule. So we can just skip the entire U sub process, that awful process, and go for those easy ones straight to the answer. So why not? Then after we know that, we're going to review our previous 4 videos. We're going to be talking about basic integrals that don't require U subs. Then we're going to be talking about indefinite U subs, definite U subs, general U subs. So if you want, before you watch this video, be sure to watch the previous 4 so that you know what we're talking about. So as we're reviewing them all mixed up, you'll be like, oh, I remember this one from this video, I remember this one from this video, and so on. These are all the integrals that appear on the AB exam, the AP Calculus exam AB portion. Also, most of the integrals that you might see on a Calculus 1 exam in college. So these are definitely certainly some very important integrals. The main thing is just knowing when to use sub and when not to use sub, and also how to carry out U subs. So that's what we're going to focus on again. But first off, we're going to talk about easy U subs. And when I talk about easy U subs, what we're going to try to do is we're going to try to skip the U sub. So what's going to be the form of these guys? Well, it's going to be some integral of a function, and the inside function, which makes it a U sub because there's an inside function, is just going to be a line. So what it's going to be is of the form mx plus b times dx. So let's just try to do this integral in general, and you'll see what I'm talking about. So what you do is, what's the u? It's going to be the inside function, so it's going to be mx plus b. We immediately take a derivative, so it's going to be du. What's the derivative of mx plus b? Well, the derivative of mx, like 5x, is 5, so the derivative is n. The derivative of b is 0, so we just multiply by dx. Then we try to change all the x's to u's, so it's going to be the integral of f prime, and then instead of mx plus b, we're going to replace it with our u here, u. Then we look for our remaining dx's. Looks like it's just dx, so we're going to take dx, and we're going to bring the m over to isolate it so we can replace it with it. So du over m. So instead of writing dx, I'm going to sub in du over m. That's why it's called U subs. It's going to be du over m, but I always like to take out my constant, so it's going to be 1 over m. Looks like I have no more x's, so I have accomplished my goal. Now I'm going to go for the integral, so it's going to be f of u, because the antiderivative of f prime of u is just f of u. Then we're going to plug in, we still have this 1 over m. Let's not forget the plus c. And then finally, what was the u? It was mx plus b. So it's going to be 1 over f of mx plus b. So what we want to do is we want to skip all of these steps and go straight to the answer. Notice it's going to be pretty easy. All we're going to do is we're going to take the antiderivative, and then we're going to, instead of multiplying by the constant like the chain rule of the derivative, the slope, so for example, the derivative of sine 3x is cosine 3x times 3, we're just going to multiply it by the reciprocal of the derivative of the inside function. So again, we're going to take the antiderivative, then we're going to multiply by the reciprocal of the inside function. So let's see how this works. So let's erase this. Let's just practice with several examples, and you'll see how quick they are. So let's do the integral of cosine of 3x. So I see, oh, this is an easy U sub. I do have to account for the U sub because there's a 3x, just like if this were a derivative, I would have to account for it. But I don't have to do the U sub process because the inside function is so easy, I can just go for the answer. So what's the integral of cosine? Well, that's just sine. Then we'll keep the same thing, the inside the same. And then instead of multiplying by 3, like we do in derivatives, we're going to just multiply by 1/3. So that's all it is, 1/3 times sine 3x plus c. So notice I can just go straight to the answer. Just take an antiderivative and multiply by the reciprocal of the inside function, which is going to be just 3. Remember that you can use sub if you want, but I feel like this is a lot easier. Skipping these easy U subs, don't actually doing the U sub process and going straight for the antiderivative. So for example, we can do several more. If you have something like 2 over 5x plus 1, well, do you know the antiderivative if you cover up 5x plus 1 and if it's just 2 over u? Well, that's ln. So it's going to be 2 times ln of this thing in the parentheses, 5x plus 1, And then all you have to do is take the multiply by the reciprocal of 5x plus 1 in the front. So that's why it's going to be 2/5. So again, nothing too crazy. You just take an antiderivative of the function that you see, and instead of multiplying by the derivative of the inside, you multiply by the reciprocal of the derivative of the inside. So for example, if you have something like e to the minus x, one of the most missed questions, you do have to do the u sub, sort of, just like you have to chain rule this if this were the derivative. But again, it's pretty easy. You just write the antiderivative. The antiderivative of e is e itself, so it's e to the minus x, and then we multiply by the reciprocal of this derivative. That's just going to be -1 because the reciprocal of -1 is -1. So it's just that. Notice how easy these questions are. You can do them very, very quickly. Let's do a few more of these just to get the hang of it. So let's say I have something like integral of secant squared of 5 minus 4x. So same thing. You should be able to recognize secant squared because it's the derivative of something. So what's the antiderivative of secant squared? That's just tan. Then you plug in 5 minus 4x. You'll write a plus c. So we can write plus c. And then what number do we want to multiply by? Well, we want to multiply by the derivative reciprocal. What is the derivative of 5 minus 4x? Keep in mind that it is based off the minus 4x. The derivative of minus 4x is -4. So we're going to put a -1/4 instead. So it's really, really similar to the chain rule in these easy questions, but instead of multiplying by the derivative of the inside function, you multiply by the reciprocal of the derivative of the inside function because you're taking antiderivatives. So something like 8 to the 3x plus 1. Again, nothing too crazy. You recognize the antiderivative of 8 to the x. Keep in mind that this is not the power rule because it's a to the x. So what's that antiderivative? It's going to be 8 to the x over ln of 8 plus c, and then we need to multiply by the derivative of the inside function's reciprocal. So what's the derivative of 3x plus 1? That's just 3. Looks like we're going to multiply by 1/3. So you notice how quickly I can do these questions as opposed to doing u is equal to 3x plus 1, du is equal to 3x. Then you start subbing in 8 to the u times du. Find dx, which is du over 3. So then you take out the constant. All that work is unnecessary if you can just go straight to this in this process. So I like this. Same thing for something like this. If you have the integral of 2 over 3 plus 5x squared, well, same thing. I don't want to do a u sub, even if there's an inside function. I'm going to see that the inside function is just a line, so I can really skip the u sub. So I'm just going to rewrite this as the 2, taking out the constant, integral of 3x plus 3 plus 5x. I'm not going to change the question. That would be blasphemous. But I am going to change the exponent because it will allow me to take this integral a little bit more easily because of the power rule. So this is going to be 2. And then just treating this as if it's just one thing because the inside function is so simple. It's just a line. And how do you do the power rule? You add 1 and flip. So it's going to be 3 plus 5x to the -1. Then you flip. Flipping -1 is the same thing as just writing -1, of course, because -1 over 1 is -1. And then you do have to multiply by the derivatives reciprocal of the inside function. That's going to be 1/5. So that's it. -2 over 5. And of course, you can check your work by just taking this derivative. So if you took this derivative, the -1 would drop this time. The negatives would cancel out. You would have -2. And then when you multiply by the derivative of the 3 plus 5x, there would be a 5. So that's why these 5's cancel. And it would be left with the integrand. So that's how you check your work. One more. Let's just do the integral of, let's say, sine of, let's say, I don't know, x over 2 pi, something weird. So same thing. You recognize that the inside function is pretty easy. It's just an x plus or minus a number times a constant. So mx plus b, where m is 1 over 2 pi in this case. So I'm just going to go straight for the integral. No u subs. So what's the integral of sine? That's minus cosine. Then you just keep the original the same. And you multiply by the reciprocal of the derivative of 1 over 2 pi times x. But the derivative of 1 over 2 pi times x is just 1 over 2 pi. So when you flip that bad boy, it's just going to be 2 pi because it was a fraction and no longer became a fraction. So this answer is just this plus c. So hopefully you can see this process. All we're doing is just taking the antiderivative of the function if the inside function is easy enough. and then we're multiplying it by the constant of this inside function flipped over, the reciprocal. So hopefully this easy U sub process will make things a little bit faster and speed you through for a lot of questions. So I'm going to erase this. And then let's now actually review for integrals. So this is the second half of the video that was promised, just practicing a lot of integrals. And the big question, of course, really two big questions. First big question is to U sub or not to U sub. Not every question is a U sub. You just need to recognize which ones are U subs. And then the second big thing is if it is a U sub, carry it out precisely. Do all the steps precisely unless you're skipping the U sub like we just did. So I'm going to do a few examples back to back or in pairs or in small groups so that you can see the difference between the different questions and you can sort of see my thought process of how to do each one. So in this case, what we're going to do is we're going to do the integral of x squared plus 1. We're going to try to keep the number small, 0 to 1 squared. Then we are going to do the integral of x squared plus 1 squared with an x in the front, with a 0 to 1. So these are two separate integrals, and basically these integrals will be done quite differently. There's a very easy way to do this integral, but you can't use that for this way. So look at these two integrals and try to spot the difference. Try to think about which one is a U sub or which one is not. Maybe neither, maybe both. I'll let you think about the question for 3 seconds. Let me close my eyes. Let me just rest them a little bit. 3, 2, 1. Let's get started. So this one is not the U sub because the U would potentially be x squared plus 1, but its derivative is not in the question because its derivative involves an x and there's no more x's. In this case, the U would be x squared plus 1 because the derivative, while not exactly in the question, is in the question up to a constant. What's the derivative of x squared plus 1? It's 2x. Oh look, there's an x. So this one is probably going to be the U sub. This one's probably not going to be the U sub. So remember that not every single integral is U sub, unfortunately, even on the AB exam. So this is going to be the expand, where you just have to algebraically manipulate it before you do the integral. So I'm going to expand it using foiling. So it's going to be x to the 4th plus 2x squared plus 1. And now I can take this antiderivative. So it looks like it's going to be, again, no U subs. What the great thing about this is that once we do this, why are we algebraically manipulating things? It's because when things are in sums and differences, that's great because you can just take them individually. So it's going to be x to the 5th over 5 plus, looks like 2x, not the best numbers in the world, unfortunately. So it's going to be 2/3 x cubed plus 1 plus x, sorry about that. Struggling with the antiderivative here, but it's just the power rule, adding 1 and flipping, adding 1 and flipping, adding 1 and flipping. So for example, this one is x cubed now, and then we flip that new exponent, so it's divided by 3. Then we're going to plug in 1 and 0. Why am I dreading this? Because the numbers look kind of nasty, but I'm going to be strong, I'm going to do them. When you plug in 1, it's actually not that bad because 1 to any number is 1. So it's 1/5 plus 2/3 plus 1. The consolation prize is that plugging in 0 is even better because everything becomes 0 because 0 to a finite number is 0. So 0 plus 0 plus 0. So it looks like this answer will be whatever 1/5 plus 2/3 plus 1 is. Integrals are annoying because they introduce fractions, but if we use common denominators, we should be good to go. This is 3/15 plus 10/15 plus 15/15. So it looks like we have 28/15 as our answer here. This is not the most organized work I've ever done, but we're going to try to put the answer of this just within this box. So again, this integral is not a U sub because if you let U be x squared plus 1, there's nothing to substitute in for that additional x. So let's see the difference in this question. In this question, it's a lot nicer because you do have U is equal to x squared plus 1, and then you can have du is equal to 2x times dx. And this is great because this x is right here where it wasn't in the previous question. So this is how what allows the U sub to work. So we're just going to take this integral. We're going to change all of our x's to u. So it's going to be u squared. Then it looks like we have an x and a dx. If we're doing the U sub correctly, if you watched our definite U sub video or indefinite U sub video, you'll know that it's in the second line. So you're just going to isolate that. It's going to be x times dx is equal to du over 2. So we have du over 2. Whenever I take my integrals, I always take out the constants. So this x times dx became du over 2. So that's great. And remember, in our definite U sub video, you do have to change the numbers as well. So when x is equal to 1, looks like u is going to be 2, because you plug it into this guy right here, the formula that says u. That seems pretty logical. Then when you plug in x is equal to 0, you're going to get u is equal to 1. That's all good. So we have an integral. Instead of u 0 and 1, we now go from 1 to 2. Keep in mind that we've forgotten about x's from here on out. We can just deal with u's because we changed everything to u's. So it looks like it's going to be 1/2 times u cubed over 3. And then we're going to plug in 1 and 2. So looks like we have 1/6, because 1/2 times 1/3 is 1/6. 1/6. And then when we plug in 2, it's going to be 2 cubed, which is 8, minus 1 cubed, which is 7, 8. Or 1 cubed, which is 1, and then you do 8 minus 1, which is 7. Sort of getting ahead of myself there, so the answer is 7, 6. So again, when you look at a question, as opposed to derivatives, where right when you see a derivative question, you just go for it, boom, 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 quotient rule, product rule, chain rule, whatever. You want to think for a second, is this a U sub or is this not a U sub, especially on the AB exam, because there's no more integration method beyond that. And if you do recognize that it's a U sub, just start doing the U sub process. But hopefully it makes sense which ones are a U sub process, because there's logical choices for the U. In this one, there's no logical choice for the U, so it was that famous expand integral where you algebraically manipulate it. But let me erase these and let's look at another 4 questions that look very similar but are done quite differently. So I'm going to erase this guy. I'm going to erase this. I'm going to erase this. So there are a lot of integrals that are fractions, and you'll see that even if fractions look similar, they're done completely different. So in my first box here, I'm going to have the integral of x squared plus x over x. Maybe we'll just write 1 here. Then I will have the, of course, the x. Then I'm going to have the integral of 1 over 1 plus x squared times dx. So another little fraction. Then I'm going to have the integral of x over x squared plus 1. And then I'm going to have the integral of just 1 over 2x plus 1. So notice that all of these integrals are fractions, but they're going to be done quite differently. Every single one is different from the other. So I'm just going to get started. So first off, try to think in your mind which one is the U sub and which one's not the U sub. For example, this one is probably not the U sub because of the same idea as before. If you let u be 1 plus x squared, its derivative is going to involve an x, but there's no longer any x's remaining besides the dx. So that's why you're going to get stuck really fast. This one is probably the U sub because its derivative of x squared plus 1 is in the question. If you let u be x squared plus 1, that derivative is 2x, so you have that x to replace it with in the U sub. This one is not 1 because of the sort of different reason. If you let u be x squared plus 1 here, that would make your du be in the denominator, which is really, really weird. Usually du is on the very outside of things. So this is not a U sub as well. And then we'll talk about this one at the very end. So let's get started here. This is what I call the split numerator. You just want to be able to recognize this. People spend a lot of time trying to U sub this, and you really get into nowhere because you can't U sub it. You have to split the integral. So you have to split the numerator. You're allowed to split numerators. You're not allowed to split denominators. So let's get started. It's another one of those algebraically manipulate before you do the question. So it's going to be x squared over x plus 1 over x. And why am I splitting the numerator, which was a legal math thing? It's because, again, it's a lot easier to do integrals when they're separate. What's x squared over x? First, simplify it before you go to the integral. So that's just x plus 1 over x. Because, of course, x squared over x is just x. And then notice that I can just do power rule here. What's the antiderivative of x? That's x squared over 2. What's the antiderivative of 1 over x? That's ln of x plus ln x plus c. And we are good to go. So again, not every integral is a U sub, and as you get more experience with these, as you practice all these examples, which is why we're doing this right now, you'll get a better feel of whether things are U subs. So let's look at this one. This one is actually the quickest one. This one is not a U sub again, because if you let u be 1 plus x squared, its derivative would be 2x, and there's no more x's to replace. This one is just a one-step question. It's just inverse tan. I've seen these questions on the AP exam as well, where do you recognize this antiderivative? If you do, it's just a 1-second question. If you don't, you're just going to get stuck and you're not going to be able to find anything. So just recognize your antiderivatives and derivatives so that you can make these easy questions very easy and very quick. So this one was the U sub because when you let u be x squared plus 1, you will get 2 times x times dx. and we have an x in dx, so this is why this is correct. We take the integral, we replace one line at a time, so we're going to replace the u's with x squared plus 1s, so that's why the u is going to be in that spot right there. Then you have x times dx, so looks like we're doing it correctly because it's in this line. It's always in your second line, that's why we're subbing in one line at a time, because that second line will be will include all of your remaining x's. So it looks like it's going to be x times dx is equal to du over 2. So how it works is we put the du on the top here. If you want, you can write 1/2, but I like to take out the constant, 1/2. You need to be able to take this antiderivative, but the antiderivative of du over u is just ln. So it's going to be 1/2 ln of u plus c. We replace the u at the very end, so it's going to be 1/2 ln of x squared plus 1. 1/2 ln of x squared plus 1. Again, as you practice more of these, it will be obvious to you that this is a u sub and this is not, because this guy is the derivative of this, where there's no x in it, and the numerator here. And then finally, this integral is also a u sub if you want, because the u sub would be u is equal to 2x plus 1. But let's practice our previous part of the video where this is an easy u sub. Let's just try to recognize the antiderivative. It's 1 over something that's just linear. It's not squared or square rooted. So this is ln as well. So it's going to be ln of whatever this is n. And then remember, you multiply by the derivative of the inside's reciprocal. What is the derivative of 2x plus 1? Well, that's just going to be the slope of 2x plus 1, which is 2. So what we're going to multiply by is not 2, because we're not doing derivatives. We're going to multiply by 1/2, because we're doing antiderivatives. So that's that. So hopefully this makes sense. Again, just take a few seconds before you do each question and try to think and ask the key question of life. To u sub or not to u sub? So let's do a few more questions, and then we'll do some general u sub questions, and then we should be good to go. So let's erase this. So try to do these two questions. Try to spend a few seconds. We're going to do, not this one, but we're going to do 1 over the square root of 1 minus x squared. So try that one. And then we're going to do something that looks pretty similar. We're going to do this one instead. What number should we put? We want the numbers to be quite key here, or else the numbers might get kind of bad. Let's not do -1. Actually, we can do -1, and we can just try numbers. And the numbers might be bad, but we'll just live with it. So we'll do 2 and 3 and 1. So just practice this question for a second, and just try to think which one is easier and which one's harder. We're going to change this one again, so sorry that I haven't written the question correctly, but now it's an x. So try these two questions, now that they're correctly written, yay, and just go for it. So I won't let you watch me, or I won't watch you as you do the questions, because some people get nervous. Just try these, and hopefully you pause the video and try them. So this one is a lot easier than this one, because this is again a memorization one. This is just inverse sine of x. You do want to recognize this. Doesn't make sense that this is a u sub, because there's no more x's beyond what's in the denominator, so it doesn't make sense for u to be 1 minus x squared, or u to be the square root of 1 minus x squared. But in this case, it does make perfect sense for the u to be the x squared minus 1. Hopefully you can recognize that it's not the square root of x squared minus 1, because that derivative is 1/2 x squared minus 1 to the negative 1/2 times 2x, and that's just so many x's that you won't have anything to replace things with. So this one is just u is equal to x squared minus 1. Then you get du is equal to 2x times dx. Now we're ready for our new integral. So it looks like we need some more space here. So it looks like our new integral is going to be the integral, changing all of our x's to u's, one line at a time. So I'm going to replace this u into here. So it's going to be square root of u. Then looks like I'm doing this correctly, because the remaining x's is in the second line, and that's how it always works. So x times dx looks like it's going to be du over 2. Not going to complain about that. It's going to be du over 2, but again, I like to take on my constants, 1/2. Finally, we have to change the numbers. When x is equal to 2, looks like we get 4 minus 1, so u is going to be 3. Trying to make these square roots, but I wasn't strong enough. When x is equal to 3, u is equal to, we plug in 3. Just keep in mind, you don't plug it into this thing. You only plug it into this thing. So it's going to be 9 minus 1, which is 8. So it looks like those are our new numbers. Then, now we're ready for the integral. Remember that when we do this integral, we forget about all these x's, because we're doing a definite u sub. So we're not going to plug back in x squared minus 1. We're not going to use 3 and 2. We change everything to u's. Let's just stick with u's. So this is going to be 1/2 the integral of u to the negative 1/2, just an intermediate step so that we can employ the power rule a little bit more easily. 3 and 8. So now it's time for the power rule. So what's the power rule here? Well, it's going to be u to the 1/2. U to the 1/2, we're going to add 1. But notice that when you add 1, you get u to the 1/2, negative 1/2 plus 1. Then you flip your new exponent, so it's 1/2 flipped is times 2. So it's going to be 2 over 2, so this cancels out actually. And you're just going to be left with 8 and 3. We're just going to plug it in even if we don't know these. It's the square root of 8 minus the square root of 3, and we're done. But hopefully these past 2, 4, 6 examples, 8 examples or so, you'll recognize when to do a U sub and when not to do a U sub. And when it is a U sub, you will just carry out the process correctly. Just focus on the steps, changing all the x's to u's, for example, including the x numbers if there's x numbers. Substituting in one line at a time and just choosing the correct u based off if its question is in the derivative or if it makes logical choice. So that's those questions. Remember that there are some questions that are sort of miscellaneous. These are our general U sub questions, so let's talk about those for a few minutes just to remind ourselves of them. Sometimes there are the questions that some students miss the most. So I'm going to do the integral of f of 3u, 3x by the way, not u. And we know that this is 1 and 4. So these are called general U subs because you don't know the actual numbers. You don't know the actual functions. It's just f. So this is going to be a given. So let's suppose that this is equal to 5. And what we want to do is we want to find the integral of f of x dx. And instead of from 1 to 4, we want to find it from 3 to 12. So these are these general U sub questions. So what I do is I recognize it's a general U sub question. I don't look at what's the given and what's the question because sometimes they're reversed. What I like to do is I like to just go straight for the U subbable one, if that's an adjective. So for the U subbable one, it's the one that has the inside function. Sometimes it'll be the given, sometimes it will be the question, but in this case, it looks like it's the given because it's f of 3x. So I'm going to start off with that and I'm going to U sub it because it's U subbable. So it's going to be u is equal to 3x, du is equal to 3 times dx. So if I change these integrals, then it's going to be, I replace the u with what it is, so it's going to be f of u. Then I have one more dx remaining, it's right here. I should be able to find it in this line, and I do. It's going to be one of those easy u subs where I can just divide by 3, no more x's. So this is going to be times du 1/3. Then I've changed the numbers because that's a key step in definite U subs, even if it's a general function. So when x is equal to 1, looks like our new u number is 3. It's going to be magically this number because that's how always these questions work. X is equal to 4, looks like u is equal to 12. So it's going to be 4 and 12. Then all I have to do is recognize, now let's look at the givens and the questions. So it looks like I want to find the integral. Sorry, when you plug in 1 and 3, this is 3. Got confused there, but we are doing the question right. So notice that we're trying to find this. This is what the question is. So what I need to do is I need to isolate this. What is this equal to? Well, this is equal to 5. So what's our answer? Just think of this as one big variable. So what is this integral? Well, it looks like we have to bring the 3 over. So that means that our answer is going to be 15. 5 times 3. Keep in mind that sometimes these things are reversed, and we're going to do an example of that in like 20 seconds from now. But if these things are reversed, it's the same process. Start off with the U subbable one, but at the very end, you'll just replace this integral instead of setting it equal. And it's just based off which one is the given and which one's not. But you just start off with the U subbable one, do the U sub, and then recognize, do I want to plug in 5 here, or do I want to set it equal to 5? And in this case, because this U subbable one is equal to 5, we let this equal to 5. But this entire integral is equal to this integral, but we only want the integral without the 1/3 because we only want f of x dx or f of u du. So all we do is we brought over the 3 and we were done. So let's look at it in reverse. Let's see if we have a question where the U subbable one is the one we want. So those are usually the easier ones that people understand, but the other one is just an equation. Just start off with the U subbable one, set an equation, and then just either plug in if you need to or solve if you need to. It just depends on which one's the given and which one's not. So in this case, what we're going to do is we're going to have this as the question instead. We're going to go 2 to 3. And this is the one we want. And we are given the fact that the integral of f of x squared, or f of x times dx equals 6, and these numbers are going to be 4 and 9. So let's do this, let's change this. So this is the question. Again, once you see that this is a general U sub question because they have an f, what you want to do is start off with a U subbable one. In the previous one, we started off with a given, the one that had the equation. But in this one, we're going to start off with a question because this is the thing you can U sub because U can be x squared. So let's start. U is equal to x squared. You let du take the derivative just like normal, dx. Then you change all your x's to u's. So it's going to be the integral of f of u. That's why we chose this u, so we can put it right there. How many x's do we have remaining? Well, it's x times dx. It's always in this line. So let's isolate x times dx. It's going to be du over 2. So it's going to be times du over 2, but I always like to take out my constant. So it's going to be 1/2 here. Then we do need to change the numbers, but the numbers will probably be these. When x is equal to 2, I don't know where 2x is there, but when x is equal to 2, the old bottom number, we plug it into the u, so our new number is going to be 4. Then when we plug in the top number, it's going to be 3. X is equal to 3, so u is equal to 9. We're going to get 4 and 9. So remember that this is the question. So because this was the U subbable one was the question, we're not going to set this equal to something. We're going to use the fact that this is 6, so we're going to take all of this because the integral from 4 to 9 of f of u du is the same thing as the integral of 4 to 9 of f of x dx. It would be the same thing as the integral of 4 to 9 f of Snorlax d Snorlax, you know. Every single time the variable of integration doesn't matter as long as you have the same sort of function here. So instead of setting this equal, because we don't know that this is equal to something, we just know that the given is equal to something, we're going to sub in. This integral is equal to this by the U sub with the 1/2 in the front. So our final answer is going to be 1/2 times 6, which is equal to 3. So in this case, we subbed in. In the last one, we said equal. But hopefully it makes sense. You're just solving a pretty simple equation with one given and one not. And it depends on which way they sort of ask the question. So finally, one last thing is I'm going to do a little table integral, and it should be pretty easy. We're doing it 2 ways in order to sort of placate everybody, depending on whether they want to do easy U subs or not. So this is going to be my little table here. It's going to be x, it's going to be f of x. Then it's going to be, let's see, what numbers do we want here? I'm going to involve, let's try to do 1, 3, and 9. Then we are going to have these numbers can be random, so we'll make them that. And then what we're going to try to do is we're going to try to do the integral of f prime of x times dx. Let's put a 2 in the front, and then we are going to go from 1 to 3. So this is the thing I want to do. Actually, I don't want to do this. I want to put a 3x. This is the point of the question. So let's put a 3x. So this is the question. So what we're going to do is we're going to do this last question 2 different ways. We're just going to do a normal U sub. And hopefully you recognize that it's a U sub because there's a 3x in here. So let's just do the U sub. U is equal to 3x. Then du is equal to 3 times dx. Now we're changing all of our x's to u's just like normal, even if this is a general question with an f. So it looks like it's going to be 2 because I always like to take out my constants. I'm going to put an integral. We chose this as our u so that we can get f prime of u. Then we have dx. It's always going to be in this line. So when we take that 3 over, it's going to be dx equals du over 3. So instead of dx, we're going to write du over 3. But we're going to take out the constant again. So it's going to be 2/3. And then finally, we do have to change the numbers. That is key. So when x is equal to 1, we plug it into here. So it looks like u is going to be 3. When x is equal to 3, that means u is equal to 9 because we plug in 3 here. 3 times 3 is 9. Those are going to be our new numbers. We are ready to go because everything is in terms of u's, including the numbers. So it's going to be 2/3 f of u, plugging in 3 and 9. And these are u numbers and not x numbers, meaning that they're not the original x's. They are 3 and 9 now. Because the antiderivative of f prime is just f of u. Then we're going to plug in 9 and 3. It's going to be 2/3 f of 9 minus f of 3. Then we're going to use this handy table. We don't even have to do any math. 2/3 hopefully I can squeeze in the answer here. 2/3 times, what's f of 9? It's -1. What's f of 3? That's 8. So it's -1 minus 8, that's -9. So it looks like our final answer is -9 times 2/3. -9 over 3 is 3 with a negative. So it looks like our final answer is -6. So we can just box our answer somewhere. We'll just put it in this nice box, it's -6. So that's how you do this question with a classic U sub. But let's try to sort of go full circle here. Let's try to do this by skipping the U sub, because this U sub should be easy enough to skip because the inside function is just a line. So how do you do this? Well, you just go straight to the integral. What's the integral of 2 times f prime of x? That's going to be 2 times f of u, or f of 3x. So f of 3x. But we need to multiply by the reciprocal of the derivatives of the inside function. So that's going to be 2 over 3. That's what we were doing previously. Then, because we didn't do the u sub, we didn't change all these x's to u's. We were just using 1 and 3. So these are x is equal to 1 and 3. But notice you get the same thing, because when you plug in 3, you'll get these u numbers. So it'll be f of 9, f of 9. Let's see if my marker can survive this last few. We're so close. And then it'll be f of 1. I've doubled this parentheses very awfully. And again, when you do this, you'll get -6. So hopefully this video was useful for you. We started and ended with easy U subs. I feel like you should practice those easy U subs when the inside function is just a line, because it just saves so much time. Notice that all of this work could have been done just by this little line right here. So remember, for those easy U subs, just take the antiderivative, keep that line inside the same, just like when you're doing the chain rule, but instead of multiplying by the derivative of the inside function, you're multiplying by the reciprocal of the derivative of the inside function, because you're taking antiderivatives. Then we also stressed how to determine whether things are U subs or not U subs. We try to mention a lot of the integrals from before, like the split numerator, the expand, and then just very common U subs where the inside function, the derivative of the inside function is in the question, so that's why it was a U sub. We also talked about ones where you just need to recognize the antiderivative. But if this was not enough sort of review, just go back and watch our previous videos. We didn't talk about some integrals that appear a little bit less often, but you still want to know them, like integrals involving absolute value, or maybe some harder U subs like the integral of sine of square root of x over square root of x. So go back on those. We also have more AB integral practice in a Girls Teach Calculus video that I'll link in the description below, where she practiced several of these sort of questions. She does just straight up polynomials, she does U subs, she does split the numerator, she does indefinite U subs, definite U subs, she has these table guys, she has the integral of the sort of general U sub questions. She even does a few fundamental theorem of calculus questions where you have to set up the fundamental theorem of calculus that we didn't talk about in this video. So be sure to check those out. That video, I believe, is very useful, where one of my former students explains things a little bit more slowly and also has a broader array of examples. Hopefully this video was useful for you. If you are in BC, we're going to continue this journey. In this playlist, what we're going to talk about is we're going to be talking about the BC integrals, integration by parts, integration by partial fractions, and improper integrals. But if you're just in AB or if you're just in Calculus 1, hopefully this was a sufficient enough review for you before you take your exam. And we definitely appreciate you watching. Be sure to watch our other videos. Even if you are in AB, you can join us for our BC integrals if you ever want to do that. But until now, thanks again for watching. Good luck with all your U subs. Just remember, do I U sub or do I not U sub? And if I do U sub, I'm very confident I'm going to do it correctly. So thanks again for watching just like normal, and I hope to see you whenever I see you. Thanks again.